now. Okay, let's share the screen where the homework is. It's right here. So these were the problems we were solving yesterday. You see them here on the screen. So you have y equals the r tangent, x r tangent, x r sine. So they pretty much were the same, except that some of them were more complex than other ones, right? Let's suppose we want, I don't know, any of these two, right? So remember that you need your formula chart next to you. Here is the back part of your formula booklet. You see this one. So you have all the properties you have to learn and also the formulas you have to know. These are the last ones we have, the trigonometric inverses, correct? So this is the ones we're going to be using. And later today, we're going to begin with this at the right, okay? So if we put this one right here, for instance, right here, J. So we have y equals the arc cosecant of x squared plus 1, correct? So you have that one. Let me just go to the board. So this is the expression. So we have to find y prime, correct? Y prime. Okay, now what is the formula we have to use as well? Our formula, remember, is derivative respect x of the arc cosecant of u is line negative u prime at the top, and then at the bottom u square root of u squared minus 1. So that's the formula we have to use. Now, you identify u is the x squared plus 1, so these are the expressions you're going to put. So y prime is going to be, you're going to put a line. U is x squared plus 1, so it's x squared plus 1. Then you open the square root, and then you're going to put here x squared plus 1 squared, x squared plus 1 squared minus 1. And then at the top, the derivative of x squared plus 1. Derivative of the x squared is 2x, derivative of the 1 is 0, so you have 2x. Okay? So there is a formula, and in some cases, it's very, very easy to really get the derivative. You see? It's just remember the formula you have to use. If you have this in your brain, there's no problem really. Okay?
Mr. Amaris, is the homework only 2 pages?
Your homework, I guess, let me see. Share screen, homework. Here is the homework. Oops. This one right here. Okay, let me see. This one.
Wait, that's C5, C05.
This one. 506. 5006, yeah, is 2, and these 2 problems.
Oh, I was in a 5007.
So you have two pages with 8 derivatives, correct? And then you have these problems of find the equation of the tangent line. Are always very, very common in calculus. Okay. So let me just go here and nobody else. Well, okay. Another problem, for instance, is what else? Let me see. Share screen. This one right here. So you see the screen. For instance, the last one, right? You have K or L. It's okay. Let's see. Suppose you want to do y equals 1 of the arc sine of 2x. Suppose you have that problem. You're just writing the problem right here on the board. So you have this one, right? Okay. Now, the first one is, well, you have the reciprocal of the arc sine, of course. This is not arc cosecant or something like that. The reciprocal of the sine is the cosecant, but not the arc sine. So be careful. So you need y prime, correct? And what we have to do is very simple. So we are going to do some algebra. So we are going to put this one as parentheses arc sine of 2x to the negative 1. So why this one? Because this is the reciprocal and the reciprocal is a power. So what I'm going to do is I'm going to write this as a power. The power is going to be negative 1. Now, I have to remember that the derivative of a power, right, is nu to the n minus 1 times u prime. So I have to get this derivative, right? So I have to get y prime is negative 1 arc sine 2x to the negative 2 times the derivative respect x of the arc sine of 2x, correct? So I'm applying this formula, exactly the same formula. You see, nothing new. I'm ready with this portion, correct? Yeah, ready with this portion. So I have to find this one, and I have to remember that, yeah, the derivative, right? The derivative of the arc sine of u, what u is a function of x, is u prime over the square root of 1 minus u squared, correct? So what I have to do is, okay, y prime is this. I'm going to do my algebra. So my algebra is negative 1 over arc sine of 2x everything squared. So I don't have negative exponents here, so I don't have to have any negative exponents here. Times. Now, this thing, well, the u is 2x, so the derivative of 2x is 2 over 1 square root of 1 minus 2x squared. Correct? And, well, the only you can do is you can put this together, or you can leave it like that. So nothing simplifies here. The only negative 1 times 2 is negative 2. And you can put this, all of them in the numerator. But this is good. Okay? Now from the homework, let's see the homework, right? Right here. The homework, yeah, let me see here. This one. Okay. In the homework, you have pretty much the same thing, correct? So, for instance, this was this ln of arctangent. As well, that's not a big deal, right? Let me just write that once. This is y equals the natural log of the arctangent of x, right? And we want y prime. So let me just go to my board. Here is. Well, you have a function inside the ln. So the first derivative you have to try is derivative of ln of u, that is u prime over u. Then the second derivative you have to try, because you need u prime, is ddx of the arctangent of u, that is u prime, and it's going to be 1 plus u squared. So you have to apply this derivative one after the other one, right? So my y prime simply is going to be, it's going to be 1 over u. This is the u, so it's going to be 1 over the arctangent of x times the derivative of the arctangent. Well, what is the derivative of the arctangent? It says, well, is u prime, so in this case, u is x, so it's 1. And then here, 1 plus x squared, because they use the x squared, so that's my answer.
Mr. Ramirez, you're recording this, right?
Yes, ma'am.
Okay, because I have to go.
No
I have
problem.
to go. All right, you're gonna post it on your Google Classroom?
In the YouTube channel.
Okay, all right,
I
thank you.
give the link in the Google Classroom.
Okay, thank you.
Take care, Mari. Bye.
Bye-bye.
Okay. Okay, Luisitos.
Sí.
Okay, right. What happened in the problems like these ones? Let me just check this one. Okay, problems like, no, not like this. And share, I need to share this one, yeah. Problems like these ones at the bottom, right here. This implicit differentiation review. Find an equation of the tangent line to the graph of the equation at the given point. So you have now arcsine of x plus arcsine of y equals pi over 2. So you have equations where the x and the y are mixed. Let me just do something like that. So this is arc, I don't know, arc cosine of x plus arc cotangent, no, arc cosine of y equals pi over 2. And the point is going to be the same. Let me just use the same point. Square root of 2 over 2, square root of 2 over 2. Correct? Let me just check this one, right? How do you do this? This is, well, pretty much the same. So remember, when you have an implicit differentiation, you have x and y mixed. You cannot solve for y. That's going to be difficult, correct? So we are going to keep it like this. So we assuming y is a function of x, correct? We are going to use the chain rule to calculate this one. So I'm going to take the derivative both sides, arc cosine of x plus arc cosine of y equals derivative of pi over 2. Remember, pi over 2 is a constant. Pi is a constant, so the derivative is 0. Then you have to use the properties of derivatives. Derivative of an addition is the addition of the derivative. So I have to take ddx of the arc cosine of x plus ddx of the arc cosine of y, correct? Equals 0, of course. And then I have to use the formulas. Remember, the formulas, let me just share screen again. The formulas are right here. Yeah, you see them? These are the formulas you have to use. Derivative of the arc cosine of u is this one right here, correct? Well, right here. So I'm going to my page on the board. So this is going to be negative derivative of the x is 1 over a square root of 1 minus the u, in this case x squared, plus, right, the x derivative of the arc cosine of y. So I have to put here negative 1, derivative of the arc cosine is 1, right? A square root of 1 minus y squared times, here is the difference, I have to take dy dx. Here is y prime, correct, at the top, so it's dy dx, and this is going to be 0. Okay, now, don't worry about these expressions. This is a number, this is a number. So remember your basic algebra. It's like you have an equation that is a 3 plus 2x equals 0. This equation in green is very easy to solve. You move the 3, and then you divide by 2, and you get the x. Well, in this case, this is the y, so I'm going to do exactly the same. So I'm going to get dy dx is, this is a negative, change to positive, so it's 1, and so I'm going to put here, negative 1 over the square root of 1 minus y squared. And here, negative 1 becomes positive, is 1 over the square root of 1 minus x squared. This is dividing, so you multiply, correct? You multiply, and then you get dy dx equals a square root of 1 minus x y squared over the square root of 1 minus x squared. So this is your derivative, correct? Now, you have now to evaluate, right? You have to evaluate at this point. Why? Because what you are asking is you need the equation of a tangent line, correct? This is the equation of a tangent line. So here, if this is the function of x, right? This equation is y minus y0 equals mx minus x0 is the equation of a tangent line. Who's the x0? This is the point x0, y0, right? And the slope is f prime in x0, or the derivative evaluated in x0, right? In this case, we're going to do the same, except that the m is going to be dy dx evaluated in x0 and y0. So you have x and y mixed, so you have to use both. So I have dy dx equals the square root of 1 minus y squared over the square root of 1 minus x squared. Then if you evaluate in the point square root of 2 over square root of 2, square root of square root of 2, you're going to have, I'm going to put here a square root of 2 over 2, a square root of 2 over 2. So you're going to put here a square root of 2 over 2 right here. So this is a square root of 1 minus the square root of 2 over 2 over the square root of 1 minus the square root of 2 over 2, right? And because these are the same, this is a 1. Really a negative 1 because I have here a negative, right? A negative. So, yeah, it's negative 1, right? So my point, my slope is negative 1. So this is 1. So the slope is negative 1. The x0, y0 is a square root of 2 over 2, a square root of 2 over 2, right? So my equation is going to be y minus y0, the square root of 2 over 2 equals negative 1, x minus the square root of 2 over 2. And this is my answer. So check the problem. This is my problem. This is the calculus part. You have to use these derivatives. Once you find the derivative using these formulas, you have to use your algebra to solve for dy dx. It's a linear equation. You solve for dy dx, right? Then, because you require this equation of a line, you have to remember how you obtain that equation. So this is my point slope formula, okay? So the point is a point on the line, so you have it, it's a square root of 2 over 2. The fx, well, in this case, you don't have the function explicit, but you have dy dx. That is going to give you the slope of the tangent line. The point you have to evaluate, and you have to use both x and y because you have x and y in the formula. You plug them in the values, you find that is negative 1, then you have the two entries you need for your line, and you write your line. So all these problems are always the same.
Okay.
Okay, Luisitos?
Mhm.
Okay. Bueno, I don't know. So 1031. If I repeat the integrals, let me just pause